tutorial that I gave you last week on water quality calculation. Then after that, we will discuss on the rest of the chapter 2, right? Because we still have some part we didn't discuss yet, which is on the nitrogen, phosphorus, DO set curve, and then finally is a sampling. Then we are done for chapter 4. Okay, and before we end our session for today, I would like to ask everyone, every group, about your progress, or if you want to ask anything, you can do so, ya. So kita mulakan lah, ya. So I will share my slide. Nampak, ya? Kita dah sampai sini, ya. That means for our lecture we are up until here, until COD. Last week we have discussed on the hardness, alkalinity, BOD and COD, if I'm not mistaken. Betul tak? Yeah. So let me recap a bit. Basically, hardness is the measurement of the minerals, especially on the calcium and magnesium, and also other minerals, right? Cations and anion. That contribute to the some water quality problem if exceed or very high in the water system. Okay, then we discuss on the alkalinity. Okay, so I would like to ask anyone, what does it mean by alkalinity? Kita recap sekejap. Alkalinity, siapa nak jawab? Siapa yang belum saya tanya lagi? Nur Soleha, alkalinity. What does it mean by alkalinity in the water system? Nur Soleha tak ada ya? Siti Atika?
The ability of water to neutralize acid.
Yes, that's correct, ya, Atika. That's good. The ability of the water to resist any pH changes, especially on the acids. Okay, that's good. So saya dah bagi contoh last week about the soda bicarbonate, examples of the alkalinity in the water system. Okay, after that we discuss on the BOD, right? Before that is oxygen demand. This one we can calculate. After that, on the BOD, biochemical oxygen demand. Can someone explain to me what do you understand by BOD? Kalau tak ada jawapan, saya kenalah panggil. Nadia Rizal. Apa yang you faham berkaitan dengan BOD? Nadia ada?
Ada, Doktor.
Ya. So BOD, listen.
BOD is a measure of the quantity of oxygen used by microorganism in oxidation of organic matter.
Yes, that's correct, Nadia. About the ability of the microorganisms, they will consume oxygen while decompose or oxidize the organic matter in the water. So if our water is dirty, got lots of the organic matter, so the bacteria will increase or active, degrading this organic matter, so they will consume the oxygen, dissolve oxygen in the water. Alright, after that is about COD. Anyone would like to try? COD pula. Lim Yu Ki?
Yes, Doctor.
Hmm. How about the COD? What do you understand by chemical oxygen demand?
To measure the oxygen requirement for a sample likely to oxidation by strong chemical oxidation.
Okay. So basically, in summarize, something that the bacteria can't do is they cannot biodegrade the chemicals in the water. For example, heavy metals or other chemicals like the discharge from the industry got lots of chemicals, right? So in this case, we need to use a strong oxidizing agent. Okay, usually we use a potassium dichromate because it has lots of oxygen. So this one, by using the process of oxidation and reduction in the lab, so we will know how much oxygen consumed. Okay, so basically COD test can measure inorganic. Okay, examples of inorganic is something not natural. This is mostly chemicals, heavy metals, right? Because it can biodegrade the inorganic, it also actually can give us information on organic. So both can be degrade or oxidized by and the information given by COD. Okay, I hope that all of you can differentiate between the BOD and COD. Okay. Okay, before I proceed to ammonia, phosphorus, eutrophication and so on in this slide, I would like to discuss on the tutorials. So when I check through the profile here, the tutorial, okay, green means you submitted. Okay, that's good that means you try the exercise. Okay, but there are some students are not submitted. This one submitted but late. Okay, merah ni late So this is the exercise for me is very important for you to know whether you understand or not. So that's good. Congratulations for those who are submitted. No marks because this is tutorials. Tutorials means more on exercise. Okay, let's see. I will discuss the answer. So all of you can check your own answer script. Boleh check sendirilah. Tapi kita akan buat sama-sama. Boleh? Ya. Okay, nampak Okay. So let's do the tutorials together. Okay, first question is about how you convert the ion, this ion, right, given 2 milligram per liter as calcium carbonate, which is on the hardness concentration, Okay, so we have calcium, magnesium, carbon dioxide. This one is the bicarbonate and carbonate ion. Okay, so the easiest way or simple or effective way on how to calculate is you construct the table like this, right? Because easy for you to do the calculation. Okay, first 83, the atomic weight is 40. Usually when we give the question, we give also the atomic weight. The atomic weight get from where?
Periodic table.
Yes, from the periodic table. And then the balance is from where? The balance from the charge of the ion, yeah? And then how to calculate the equivalent weight?
The atomic weight divided by the valence.
Yes, so this one that means senang kan? Uh, saya tulis dulu. Tak keluar. Oh, ada. Okay, 40 divide by 2, that means this one 20. So yang ini 83, then yang ini berapa ni? 50 divide by 20, betul? So how much do you get? Ini contoh saja. Berapa? 207.5, kejap Semua dapat? Okay, so this is very straightforward, okay? So second one, berapa pula? So this one 24.3 divided by 2, that means how much? Macam ni? Siapa yang buat ni?
12.155.
Yes, senang kan? Kira saja. 12.15 ya. So ikut sajalah, so you can follow. So this one is 27 times 50 because we use calcium carbonate as our reference. Calcium carbonate, this is the equivalent weight for the calcium carbonate. Divide by 12.15. So berapa? Loh sini berapa loh sini? Loh sini bahasa gem. Mu ayat? Berapa punya jawapan? Buat tak?
111.11.
111 betul semua? Semua dapat Okay, CO2 saya tak bagi atomic weight. Atomic weight ni boleh kira. How much this one for the atomic weight? For carbon dengan oksigen ada 2 atom. So carbon berapa? Atomic weight. Muayyad Mansur? How much this one, the atomic weight? Oh yes, correct. Muayyad tak ada? Muayyad? Where are you?
Doctor.
How
Yes,
much-
doctor.
how
Can you
much
hear me?
atomic weight for the carbon dioxide here? This one. How you calculate?
24.
24. Okay, let's us to calculate 12 because carbon is 12, then plus with oxygen is 16 times 2. So how much? Berapa ni?
20.
44. 44 eh? This one is 44. Betul eh? You need to revise again the calculation how to get this atomic weight. Okay, let me repeat.
Oh, yes.
For carbon.
Yes.
Okay. Okay, this one you must be confused because we didn't know the valence, the charge, there is no charge, but this is actually from the reaction. Okay, basically the reaction, based on the reaction, the valence is 2. Okay, so how much is the equivalent weight here? Very simple, 44 divided by 2.
By 2.
So 20.
24.
Okay, so now we can calculate the hardness. 48 times 50 divided by 22. Then how much you get? Yes, Jasmine dah dapat Jasmine said 109.09. Yes, that's correct. 109.09. Betul. Okay. Okay. Next is bicarbonate HCO3 2 negative. Actually ada negatif kat sini 2 negative. Tak letak Okay, how much is the atomic weight? Alright, Moya said 110. The rest? Siapa nak buat ni? Kevin Chai Chizian. Kevin ada?
Ada doktor.
Berapa?
Hmm. 61.
61. Okay, 1 plus what? 12 plus 16 times 3, betul? Then you got what? How much? 61. Is it correct, Kevin?
Yes.
61, okay. 61 and then the value is 2. Alright, so how much is the equivalent weight? In here, 61 divided by 2, so how much? 30.5. So how much is in here? So given concentration is 0 times 50 divided by 30.5, betul? So berapa? Kira. So how much? Devi, how much?
360.6.
316.6. Yes.
50 doctor.
Oh, silap Dan main tulis. 360. 360 point apa tadi? 66. Okay. Okay, last is our carbonate So how much this one? The atomic weight. Siapa yang dah buat? Ashraf? Yes. Wah, cepat Jasmine Okay, 60. So how kan macam mana kira? So 12 plus 16 times 3. Betul? So we got 60 Jasmine, betul? Alright, so this is very straightforward. 60 divided by 2, 30. So we have 15 times 50 divided by 30. So how much? Ini berapa? 25. Ya, Auni? Ya, Ahmad Hakim. Okay, 25. Okay, that's really simple.
Doktor,
Ya.
nak tanya untuk HCO3 tu, dekat author dia tulis jawapan 180.
100
80.
Maknanya ni negatif 1 lah Okay. Nanti saya cek balik. Dia kalau 1 yang penting you tahu kira lah
Doktor,
Ya.
kenapa yang CO2 balance dia 2?
Sebab sebab dia daripada reaction tadi saya dah sebut from the reaction. Ni gas kan? Gas, we have usually the hydrogen bicarbonate gases and it has 2 hydrogens to produce the CO2. Ini kompleks sikit ni. Sekejap saya cek balik. Sebenarnya 1 ke 2 ni? Sebenarnya kita 1 je. Saya tak tahu. Okay, setahu saya kalau bicarbonate ni HCO3 actually negative 1 Okay. So saya rasa kita kena betulkan lagi. It's not 2 So kita betulkan sekejap. So this one ni nak buangkan ini. Okay. Tak boleh pun, sekejap Okay, yang ni actually negative 1. Okay. 1 bukannya 2. So in here is 1. So that means this one nanti kita betulkan balik. Betul lah. So berapa jawapan dia sepatutnya? Ini kenapa saya buang? Okay. So this one that means 61 dengan saya 61 kan? Ini satu kan? 61. So 220 times with 50 divided by
Doktor, Doktor no use share screen.
Saya apa?
Doktor baru share screen lagi.
Sorry, okay. Thank you. Nampak? Okay. Okay, that means previously I think we made some mistake. Saya pun confused Ni actually only one charge So only one, negative 1. So we do the calculation like before. Calculate the atomic weight and then 61 divided by 1. So this is the equivalent weight is 61. So this is given. times 50 because we refer the calcium carbonate as a hardness divided by 61. So how much is this one? The answer berapa?
180.
150.
80.3.
Tak dengar lah sorry. 180.3 eh? Okay. Betul?
Betul.
Okay. So ikut yang ni lah ya. Okay dah. Done eh. So you can check your own answer in the you submitted the tutorials, then you can have a look. Okay, then next is question 2. Okay, for this question, given the concentration analysis for water sample with the constituents like this, then you need to calculate the alkalinity and then determine the total carbonate and non-carbonate hardness and construct a bar chart of the compound ya. Ini saya tak bawa di bar chart dia. Alright, so you can check here. So I already put this one. Ni macam kita dah pernah buat last week. Sama tak? Yang last week punya. Anyone?
Sama
Okay.
doktor.
Itulah. Sama dengan just I found out that this is the same question that I discussed last week, but it's okay. You can have a look. Okay, the conclusion is same. Okay, to calculate the hardness for each of the constituents for the ions, right? We'll do like this. Okay, the thing is only for the what? For the pH because because pH doesn't give us information on the milligram per liter concentration kan. So we need to find out ourselves. Kadang detect, kadang tak detect semipan ni. Sekejap ada. So H plus dengan OH negatif. Ni betul ke ni? pH berapa? 10. 10. 7. Tapi ini kita dah discuss you can check back again. Okay, then from here we can calculate the alkalinity. Okay, so for the alkalinity means we need to consider the carbonate, bicarbonate plus OH negative plus negative with minus. How much did you calculate? Apa yang dah buat?
77.8.
77.8. Sekejap saya check saya punya skema dulu. Sekejap 77.8 Okey. Yang lain dapat sama? Sebab ini saya dah calculate, saya kena semak balik. $77.8. Saya tulis ni 78. So semua lebih kurang lah 78. Betul? Sekejap saya share. Betul Sekejap saya share sekejap. Nanti saya share lah ni untuk dalam auto. Ni Okay. So you can check. We already also did some exercise last week. I think quite same question. I'm not sure actually. Okay, this is how to calculate the H plus and OH negative. Then this is to calculate the alkalinity based on above table. This one from the hardness concentration. Okay, so 78. So carbonate 41. This is the carbonate. Bicarbonate is 32. Kemudian ini 5 times 1 and 5. So 78. Boleh Okay, this is the example the flash bar chart Okay. Okay, saya nak teruskan lagi untuk another question for question number 3. Boleh? About the glutamic acid. Okay, before that, I would like to ask, what does it mean by theoretical oxygen demand? Ada siapa yang dah study? Zo. What does it mean by theoretical oxygen demand? Zozen.
It is the amount of oxygen required to oxidize the substance. It is amount of oxygen required to oxidize a substance to carbon dioxide and water, H2O.
Yes. Actually, this is a natural process, but we can did the calculation in order for us to know in theory how much actually the oxygen demand. Okay, that means oxygen demand means how much they use to degrade this substance. In this case, the substance is glutamic acid. Glutamic acid ni apa Saya lupa dah. Apa dia? Give me examples of the glutamic acid. Is it from food or what? Oh, okay. So this is the amino acid that used by almost all the living things in the biosynthesis of proteins. So the function is to form proteins. Okay. So glutamic acid is something useful for our body. So we know how much this substance can biodegrade, right? Then we know lah berapa banyak dia punya oxygen. Okay, so we have this reaction, right? And then you can calculate by using this equation given 63 of glutamic acid, right? So you need to compute the gram molecular weight of glutamic acid and oxygen consumed by this reaction. Okay, first of all, actually you need to calculate the balance of the reaction, right? So in here we have 2 times of reactions. So carbon, sini 5, in here 5. So okay. So that means balance. Ni dah chemistry sikit ni, tapi tak banyak pun, jangan risau. Sikit je. 5 kat sini. Ini 5. So betul. Hydrogen 9 kat sini. So dekat sini ada berapa ni? 3 kali 2, 6. Okay, 6. Campur 3, 9. Dapat 3 sini kan? So 9. Okay, 9. Okay. So oxygen in here is a 4. 4. Tapi oxygen ada lagi ini 4.5. Tapi sebabkan oksigen ada lagi kat bawah, kan dia ada, mana tak selesai lagi. So how much is the oxygen in here? Sekejap. 4. 4.5 kali 2 apa? 9 kan? 9 campur dengan 4, 13. Campurkan dengan sini 4, 13 campur 4, 17. 17. Right. So ini maknanya oksigen ialah 9 sini 9, 4, 13, 13, 13 plus with 4, 17. Betul Semua dapat? Okay, let's see from here. Oxygen means here 10, 10. Campur dengan 3 sebab kat sini ada 3 for the combined molecules. So 13 plus 13 plus 3, 16 plus 1, 17. Betul? So balance lah. Get it? Guys? Faham? Kena check dulu balancing the balance. They must balance between the apa namanya? This one, the left side dengan right side ni. Mesti balance ya. Itu paling penting, you kena check lah. Sekiranya adalah soalan ni ya. Okay. Okay, nitrogen. Dia satu. Sekejap. Nitrogen satu. 2. 1, 2. So betul, nitrogen just got 2 molecules Okay, then you can compute the molecular weight of the glutamic acid and oxygen consumed. First, you need to calculate based on this above reaction the glutamic acid. That means in here you need to calculate. So macam dapat 1.7 dekat sini 12 times 5 plus 1 times 9 plus saya tunjukkan satu lah 16 times 4 plus nitrogen berapa? How much is the nitrogen?
14.
Yes, 14. So kalau betul lah 147. Oksigen pun sama. So 208. Okay, dah dapat semua ni, then you can calculate the theoretical oxygen demand. This is given. So this is from the gram molecular weight for the oxygen divide by gram molecular weight for glutamic acid. Then you can get 89.15 mg per liter. Semua dapat?
Dapat.
Okay, Awni dapat. Tilaka dapat? Have you tried?
Dapat doktor.
Okay, that's good. So we move to our last question I think. Betul? Lama dah ada penunjuk jawapan, tak apalah. Okay, BOD5 and ultimate BOD. Ultimate BOD biasanya kita sebut sebagai L naught. Okay, you can refer in the slide L naught. Ultimate means the super maximums of the BOD reaction. Okay, always remember the degradation. Sometimes they call it as a degradation. Ini paling mudah lah. Okay, sometimes they call it as a composition, oxidization. Sebenarnya konsep dia, the concept is similar. They are required time to degrade, right? The bacteria is like living things, right? It takes time for them to doing this process. So always they have this what we call it acceleration rate. Means this one usually must refer to the temperature, the influence from the temperature and also time. Okay. Okay, in this case is very straightforward. You're using this equation, right? So we can but you must understand which one is which. So this one is BOD5 and this one is the ultimate. Ultimate BOD usually higher than our BOD5. Yelah, biasalah BOD5 5 days. 5 days of the microorganism to do the decomposition process. But usually in the water system, they have lots of time, energy for them to degrade. Okay, due to the complexity, maybe they have a protein, like protein not easy to biodegrade, even it is organic. So it takes their maybe kalau kita boleh kira masa boleh ultimate BOD maybe take sampai maybe 10 days, it depends. So the BOD will increase the rate. So we can calculate the reaction rate, maknanya kecepatan dia, how does it performance, is it very fast or no? So in here, we can use this equation, we calculate, so based on the 5 days in here, time, so we can calculate the K value. The K value is a 0.115 per day. So you can check in the slide, what does it mean by 0.115? Is it the normal rate? They are progressing okay or fast or slow? Okay. So I think that's for the tutorials, our first tutorial on the water quality. So every chapter for the calculation part, I will give you question for exercise. You can do, this exercise we will discuss during the lecture. Okay. Any question for tutorial before I proceed with the slide?
So far, no.
Alright, thank you, May. Okay, next, I would like to discuss with all of you about the nitrogen. Yeah. So usually when we talk about the nitrogen, it is a form of nutrients. Okay, nutrients. Yeah. Nutrients mean something that can give food source to our plants, right? But if it is very highly concentrated, it gives a harmful to our water quality. Okay, so this is a part of the nutrients, which is nitrogen. Okay, from where we get this nitrogen source, I think you can read or you can have a look on this nutrient cycle. Basically, the source is from the fertilizers. Okay, beside fertilizers also we have this acid deposition, and also from the leachate. Leachate pun one of the source of the high nutrients content. Leachate. Anyone ever heard about leachate? Air daripada sampah, from the landfill. Okay. The air larian sampah from our landfill. So it produce leachate because I've involved one of the project in one of the landfill in Separangam near to our campus. So the problem of this water quality at that river is due to the leachate disposal from the landfill. So this gave a very bad quality on the water. So that when the water is really contaminated, then the water treatment plant, our logi air Sri Gading Sri Gading pula, SAJ from our Rand Hill SAJ, they cannot treat the water. So that means sometimes they need to close the system, their treatment. Okay, so I think you can read this one. Okay, the red one means the something that harmful to our environment. The red one is hazardous. That means if the nitrates, because nitrogen can convert into nitrates from the bacteria. The bacteria is two types, which is the Nitrosomonas and Nitrobacter. From the discharge or from the process of deposit of this, for example, animals punya sisa lah, sisa dia. Okay, dia akan masuk ke dalam our river system. So from the fertilizer also, the runoff can go into our water system. Ini yang bahaya, disrupt process of the water supply. Okay, so naturally it can produce by the volcano. Okay, but in Malaysia we don't have that. Basically our source is from the burning of fuel and also the inorganic fertilizers production. So it can produce the nitrogen in the atmosphere, nitrogen gas. So during the what we call it, precipitation, so nitrogen will go to this terrestrial daratan, okay, in the soil system. Okay, the soil system, okay, it makes the process of the bacteria conversion. Okay, so it got this nitrate in the soil, taken up by the plants. The animals will eat the plants, right? They discharge, okay, nanti dia akan kembali semula. They will return their deposit into the water system. Macam itulah. Okay. So they are related to the ammonia levels in the soil as well kat sini. Ada bau macam baja, itulah bau nitrogen Okay, next is the phosphorus. So phosphorus, I think you are not ada misconception. This is what we call that nutrients. Actually, it's a good nutrients for us. We need the phosphorus in order for us to live, but some of the phosphate for the larger scale, they want to make the fertilizers. So this actually can leach the phosphate into the stream. Okay, the active phosphorus is the phosphate where it can give the runoff into the system, the water system kat dalam air ni lah. Fertilizer and also the sewage. Okay. Sewage, okay, in Malaysia we do have the sewage treatment plant, air kumbahan. That means from your toilets, they will pipe flow into this our STP. We do have here in UTHM. If you want to make a visit, you can near to KTF Tun Fatimah. Okay, actually last week I just make a visit because we have some project. So okay, I didn't smell any ammonia levels. That means the system is operates quite well. Okay, but if there is some what we call that inclusions or discharge of the phosphate from the sewage, this is quite harmful to the water quality because the runoff, not talking about the UTHM but maybe the other side, if the system is not operating efficiently, they will discharge this through the runoff into the water system. Okay, the phosphate also can come from the mining area, okay, from the natural or geological factor. So they can also contribute to the phosphate level in the water system. Okay. Okay, this is the problem of the high concentrations of nitrogen and phosphorus. We call it as a eutrophication. So in UTHM, if you see this kind of algae bloom, right? It looks like, okay, this is very good because it's greeny, but if this is too much, actually the aquatic life in the water cannot survive because they need sunlight to do their process photosynthesis, and also the other plants. So this is the indications of poor water quality due to the eutrophication. Okay, some of the algal bloom also they have this HAB. You can Google harmful algal bloom. Okay, they have some substance that really toxic, toxic to the environment. Itu bahaya. Okay. Next, last part for the water quality parameter is the microbial indicator, which means we can use these terms of macroinvertebrate. Siapa tahu? What does it mean by macroinvertebrate? Macroinvertebrata in bio. No idea, Okay. Okay, first, microbial indicators, we use some of the pathogens. Pathogens mean the bacteria that can cause disease. So usually for water quality, we will check on the total coliform, TC, fecal coliform, FC, and also E. coli. Okay, from the water. This is the common testing. Okay. Okay, this is the pathogenic organisms. Okay, now we are very close. About the virus is quite common because of the coronavirus and so on. Very, complex this microbiome indicator. So beside this COVID and so on, we have lots of these actually living things, okay, micro, very tiny, that actually available in our water system. So if we actually give activate these viruses, it can give us disease. Okay, so for example, real viruses and so on, because virus is we cannot remove by using just antibiotics. Very difficult. Yeah. Okay, if we are infected by just bacteria, just a normal bacteria, like suddenly we got this fever, okay, diarrhea and so on, easy. Sometimes you see the doctor, you will get the antibiotics, right? The antibiotics mean it will kill all these bacteria. But for the virus, no, it's very persistent in our body. Okay. Okay, protozoa and also the helminth, some of the bookworm, okay, roundworm, tapeworm, okay. That's why even in the toilet, we need to wear our, what we call that, to protect our, what we call, um, from the worm, we need to wear a slipper because sometimes we didn't see this type of the worm, because even though that you brush your toilets every day, still it available actually the worm. So we need to be careful. And also if you are always playing with what we call that sport activity, right? Hiking, trekking, okay, this kind of lintah ke, okay, worm, you can easily get if you are not concerned on the protection lah. Okay, this one I think you can read yourself. Okay. Okay, one of the indicator for the water quality is we use the microinvertebrate. So what does it mean by microinvertebrate? Is we use this, apa nama ni? Serangga, beetles or bugs, yeah. So these creatures, or we call it as a microinvertebrate, is actually giving us information about the water quality, because they live in this ecosystem. And actually if you have time to Google about the ecology, okay, each of these species in terms of size, color, and their quantity, I think that's very helpful much to give information about the water quality in that particular area. Okay. Okay, usually the ecologists will collect these microinvertebrates. Okay, usually, for example, they found the butterfly, caterpillar. Kalau pepatung apa dia dalam bahasa Inggeris? Pepatung? Saya lupa dah.
Dragonfly.
Yes, dragonfly. Actually, if the color is too dark, right, and then it's small, that's actually give information on the water level is not really good. Same with butterfly. If butterfly is the bright in color, okay, colorful, and the size, because ada dia punya kategori saya tak bawa kat sini. Then we know that these microinvertebrates are living healthily. If not, they are very small in size, and also the color is not really bright. It's something like that. Okay. Besides the what we call dragonfly, the butterfly, that's the easiest one, right? You also can collect and see the apa binatang ni nama dia dalam air ni. Ni lah semua serangga ni. Also in the water like the crayfish and so on. Okay, so that's one of the indicator to identify whether our water quality is good condition or no. Okay, in the water system. Okay, so far is there any question? Actually, during my, I think last time we did some activity with our students, and then we brought the students to Tasik G3 to find these, I mean, microinvertebrates, so that they can record in terms of the color, how much, the size, and we gave them the scale. Okay, for these animals or microinvertebrate should be this size. But after do the scaling, we need to release them back again in the water system. So this is very interesting to know, because our surrounding actually give us information without our knowing. Yeah. All right. So let me proceed. Boleh? Boleh
Boleh.
Okay, next is about the river monitoring tool, which is on the diesel oxygen depletion. Okay, so based from this photo, what do you understand? I give you maybe 2 or 3 minutes to understand this figure. Then volunteer first, okay, to explain about this figure. If no, then I will ask randomly, yeah. Okay, try first. Okay dah. Jadi siapa nak try? Arwindran? Arwindan Prabhu? Kenapa tak ada suara ke apa? You don't have this one? The speaker what? My problem. Okay lah. Chi and Kai. Are you there? Tak ada. Jaswin, do you want to try? Jaswin. Explain about the figure. Jaswin tak ada? Jaswin Murugia? Semua senyap je ni. Jaswin, please explain about the figure. Open your mic eh. Senyap je. Auni. Lee, you want to try?
Let's try.
Yes, sure. Good. Semangat kan? Please try. You can try Lee. But you need to open your mic.
Sorry. So from the direction of flow, there are the fish and other animals, but with the point that the waste was polluted the stream, so the stream does not have the ability to cleanse itself, so they will have the exist of trash fish to clean the rubbish, and to the point of the septic zone, the oxygen demand was decreased and not suitable for the animal or fish to survive. So there will be extinct of the fish and only fungi or worms or bacteria.
Okay.
So after the fish, the fungi, worm and bacteria decompose the waste, the zone will be come to recovery zone where the trash fish and others were able to survive until the clean zone. The water will become normal clean.
Okay. That's good. That's good. Good try, Lee.
Okay, thank you, Doctor.
That's good. Okay, thanks Ali for your explanations. Okay, Okay, let me explain ya. For this river monitoring tool, actually the river system, they have the purification or natural purification, gitu we call it, natural purification process. So in here we can explain by using this figure, because this has been researched by the scientists Streeter and Phelps. Okay, for example in here, okay, this is the clean zone, right? But if there is what we call that some of the point of discharge happens in here, like you can see at this bottom, the discharge started from the decomposition, discharge of the waste, pollution lah, pollution, ini hitam ni okay, started at the decomposition zone. Okay, this is the healthy zone, which means at the level of the sufficient of our dissolved oxygen DO. Okay, they live very healthy. So they have this big fish. Okay, they have this trout, perch, bass, any fish now that can survive in this condition. But suddenly, if there is a point of discharge here, the pollution comes and enter to this our water system, then they start to decrease the DO level. Okay, now we are talking about the oxygen in the water. So when the this happens, the drop of the DO, but in this condition, when the decomposition happens, the trash waste, in Malaysia we call it as a ikan keli, ikan keli, ikan keli lah biasanya. Ikan apa yang boleh hidup dalam kawasan yang kotor? Yang saya tahu ikan keli. Ikan apa lagi yang siapa-siapa yang tahu? Ikan keli tu yang dia, ikan keli means the body has some slimy and dark, apa namanya, black kan. It's because they are very what we call good to live in that conditions of low pH, low DO and dirty water. Beside ikan keli, apa lagi ikan yang suitable?
Belut.
Belut. Okay, ikan talapia pun talapia ikan talapia pun sama. Okay, talapia boleh ada kata bela, ada yang tak bela. But for example, last week when I went to the STP, right? STP tu sewage treatment plant so they process the wastewater air kumbahan from our buildings in UTHM, right? And then the water discharge into the final discharge into the Sungai Semburong sebenarnya. Belakang tu ada Sungai Semburong. And then the officer, the one that what we call that in charge of the system, they said, oh doktor, dekat kawasan ni banyak sangat ikan. Ikan talapia ada, ikan keli I'm not sure, tapi kata talapia banyak. Okay, so that means they are one of the factor is they like to have this highly nutrients water. Okay, the DO I think tak adalah turun sangat. So that kind of fish, macam tu. Tapi yang lebih sesuai kat sini ialah ikan keli lah. Ikan keli dia memang hidup dalam kawasan yang kotor. Ikan bandaraya kan tapi sedap kan? Siapa yang makan ikan keli? Kalau dekat Pak Raja ni ikan keli buat masak apa? Pecel lele
Sedap, doktor.
Tak pernah? Kau pernah makan? Ikan keli?
Pernah.
So you should try. Very nice.
Pedas.
Pedas sebab dia guna rencah cili padi lah kan. Tapi the ikan itself is a very tasty lah. So siapa yang belum cuba boleh tanyalah. Maksudnya the fish is come from, adakah orang bela ataupun mustahil lah daripada satu tank, tapi pegawai tu kata banyak je orang memancing kat belakang tu. Okay, this type of the fish can survive in this decomposition zone. Okay, for very the DO can drop until 2 p.m. So in here, there's no fish can survive. Alright. Only some of the slush worm bacteria can survive in this condition, yeah? Where if the pollution is very high, highly concentrated, so it can reach to 2 ppm. But okay, as you know that river is, the water is moving, flowing, right? So it can capture back the oxygen level from the atmosphere actually. Okay, dia akan memberi apa ni, natural purification themselves. So it can increase the during the recovery zone and getting back to normal. Okay, but it takes times. So by using this equation, we can calculate, okay, how much is the DO levels that is critical, and also the distance that makes the DO drop to the certain levels. Yeah. So these are the information of the water purification system, or by using the DO set curve, right? So actually all the river have the capacity to purify themselves. They can heal themselves, okay, because the water is running and moving. So that means they can capture the oxygen from the atmosphere. As long as the discharge of the oxygen demand is within the self purification capacity, so the DO will actually they can recover the DO themselves. Okay, this one you can read. Okay, this is the models, right? So this is the travel time, and also this is the dissolved oxygen level. So we can calculate how much is the DO that drop this one at a certain time. Hari ke berapa dia drop? Okay, or maybe the deficit, the DO, based on the DO concentration. Okay, this is developed, the mass balance approach is developed by the Sitter and Phelps in 1925. He described the river as a plug flow vector. So mass balance, okay, in and out must be balanced. Okay, like this. Discharge part means when there is some discharge of pollutants in here in our river system. So it explained through this plug flow system, where the mass of the BOD we calculate as a BOD because easy for us to know the organic or strength of the pollution in the river and DO. Usually BOD and DO. Okay, BOD and DO. So this is the inclusions of the pollution. Okay, in terms of BOD, we calculate based on the BOD and the DO level, and then this is the waste stream. Maknanya ni pollution yang masuk lah. Okay, the discharge. Yang ni lah. Okay, so the combinations of this river flow with the discharge is the mixing BOD. Itu cara dia. Okay, so we can calculate in terms of this mixing, right? So this is the river flow. Usually the DO is what we call normal. BOD of the river is normal. But if there is inclusions of the waste, the pollution, so we can calculate the mix, the combined flow, the mix DO and also the mix of BOD. Berapa yang tercampur ni, mix with the waste or pollution. Okay, yang ni yang kita punya river lah, our river condition. Okay. So we can calculate the initial dissolved oxygen by using this concentration. So this is the Q is a flow of the river. This is DO kan. Waste, DO waste. Q is the flow for river. This one is river. Then kita combine the flow. Right. And this is to measure the DO for DO. DO apa ni? Initial dissolved oxygen deficit. Then we can also calculate the ultimate BOD concentration. Just, I mean the calculation is same, right? You must combine the waste with river in terms of BOD, then divide by their Q, the flow, both waste and river. Then you can get this ultimate DOD expression. Okay, this is the saturation value for DO in the fresh water according to the saturated atmosphere. This is based on the temperature. For example, temperature is 20 in our country. So how much is the dissolved oxygen and also the saturated vapor pressure. Okay, then this is if you want to know the reaeration rate, and this is the deoxygenation rate. Okay, but finally we want to know how much is the, okay, this is the BOD ultimate, and this is the rate of the deoxygenation. Alright, this is the rate, the K value, and DO as function of time. Okay, ini penting ni. Okay, for this question actually, if it appears in test or final, we will give you the, what we call it, formula. The thing is on how you need to insert your value in the formula. So usually for this question, they will ask you on calculate the critical time and also the DO, dissolved oxygen. The critical time, that's the DO drop, and also the dissolved oxygen very, what we call it, very low at that critical time. Okay, this is the examples of the equation for river monitoring tool by using the DO set curve. Yeah. Okay, for example, this charge is 37 cubic foot square, okay, of treated sewage having an ultimate BOD, right? And 1.5 milligram per liter DO into the river of the 250 ZPS and velocity. Upstream of the discharge point, the river has a BOD of and DO 7.6. Determine the critical DO and critical distance. So better if you can do the, what we call it, information and put in this like this. Discharge the waste untuk waste 30 CFS, BOD 28, untuk river DO ialah 1.8 and flow Q 250. Ini untuk discharge is must be flow lah, QW. Right. DO 1.8 and velocity 1.2 ft per s. Upstream of the discharge point, the river has a BOD upstream of the discharge point. Okay. So the first one step is you can calculate the initial dissolved oxygen concentration. Semua given Okay, DO for waste, Q for waste, Q is the flow rate. Okay, DO for the waste, R for river. So 37, 1.8, 250 times 7.6, combine, so you can get 30 milligram per liter lah. Okay. And then you can calculate the initial dissolved oxygen deficit, saturated minus dengan DO. Saturated ni dia bagi ataupun from the question ya. Macam mana? Oh, given. Kita nampak sini. 8.5 dia bagi Kalau tak bagi kita kena cari 1.65. Then you can calculate the ultimate BOD concentration. Okay, ultimate. The step is same, but you need to calculate the LW, the ultimate BOD. Information data on the BOD. So Q is still the flow times with the BOD for waste. Okay, yang ni pun sama. Then you can get 6.75 for the mix 6 initial concentration. Okay, so this is the concentration to concentration the formula to get the reaction rate given, and then you can insert into this critical time. So if you have this KR and KD, then you can get this information from the DO apa tadi? DA tu ialah DO deficit kan? Initial DO deficit. So 1.65. Ini DO deficit. Then you can solve the equation. Then you can get the critical time happens is 1 day, 1.05 day, 07 day. And then you can calculate the critical distance in here if you using the given equation. Okay, from the day, then you can get yes.
The value of KR and KD will be given by the question.
Yes, given kat sini. Given KD and also the KR, reaction rate and deoxygenation. Given
Alright, doctor. Thank you, doctor.
Okay. Just masuk-masukkan sajalah. Tadi okay, dah sampai ke apa saya? Critical distance, right? This is more on the conversion, right? Conversion, then you can calculate the DO critical time. Masuk-masukkan je sebenarnya. Nampak agak susah kan? Then you can calculate the DO deficit during the critical time. Okay. So kalau you tak buat, tak try, then you didn't know. Should I change to the tutorial for this quiz 3 or what? Tanya silakan. But I prefer if you can make it as a quiz so that everyone are very serious about it. Then you can submit in the author. I will put after this in the author. Boleh? So you can submit to me by Sunday next week. Boleh? Before Sunday pun bagus for your quiz 3. Remember that we have before quiz 1 online to cover on chapter 1 and 2, is it? No, only 1. And then last week we did also online quiz to cover chapter 3 and 4. 2 and 3. Sorry confused. Betul? So we already done 2 quizzes, then this is another one. Boleh kena try lah. Sebenarnya if you refer to our in the slide the example, it should be okay. So I will put in the author. Okay. I put in the author and then I'll set the due date lah for next week. Before 12 midnight on Sunday. If you can submit this week, it should be okay. That will be good. Okay? Online pula. Inilah this quiz. Okay, just a bit. Okay, is there any questions so far regarding to the DO set curve or Rebo monitoring tool? Ada? Okay, if you can understand this figure, this schematic diagram about how the river water react to the pollution and how this pollution can decrease the DO level in the water system, but actually at a certain time they can recover themselves and purify, healing themselves to get their DO back to normal. So in the DO set curve, we can calculate how much is the time critical, the DO critical, that this one, especially during this the DO drop. Boleh Okay, let me repeat again. Okay, first is the clean zone. This is the healthy river. Okay, so we have lots of this aquatic life. The fish can live healthily. Okay, suddenly it has this discharge from the pollution in here, right? One of waste or discharge that make the DO will decompose or drop. Okay, until 2 p.m. To 2 ppm. Okay, so in here only the fish that can survive into this dirty condition can live, right? In here, for example, the trash fish, carp, ikan gar, leeches, okay, lintai. Leeches apa? Lintai. Then there's no fish can survive at this DO level, very little. So the only can survive is slush worm, bacteria, and so on, and certain fish. Okay, during the recovery zone, because you must remember that water is running, flowing. Okay, as long as it's running, so it can capture back the oxygen from the atmosphere. So again, the recovery zone, the trash fish can survive, but finally it can capture back to the normal, and we can get back because the DO level is sufficient, then we can get back this fish. Okay, so this can be explained by using this plug flow terpanggil equation. So from the model DO set curve. Okay, so in here based on the mass balance. Ni yang tadi inclusion tadi kan? Yang waste from the pollution entering. So this is our current river. The flow, the DO levels and also the BOD. Okay. So this is the information. Then we can calculate the combine. Ini yang penting lah. Okay. So you can see this example. Okay, the combinations of mixing rate. Then you can calculate the critical time, critical distance, critical DO and also the critical DO deficit. Then you can try this one, Any other question? If no, I will proceed to just a bit on the water sampling, And then we are done for today. No. Before we done, I will ask around about your progress for project. Boleh Okay. One of the criteria of the good data water quality is based on the water sampling. If your water sampling is incorrect, then your data also not accurate. So this is very important for you to, at the beginning, you know how to collect your water accurately. Because this is very important aspect for you to provide your data verification or validation. Because if you give the information wrong, then what will happen? Sebenarnya dia, for example, the river is polluted, but maybe during the sampling you are not taking a lot of the consideration, that then the data is okay, good. So it will actually give a reflect on the decision of the treatment. So this is a very big responsibility. Okay? Jadi the process is you must make sure that you follow the standard, right? Next semester, for example, you will be taking a laboratory for environment. So this is one of the aspect that we will teach or concern about the sampling. Okay, at the beginning, from the planning, until preparation, sampling, transportation, until the analyze, we need to record. We need to record and also follow all the procedure. Okay, bottle sample, can we just use our mineral bottle? Boleh ke?
I think cannot.
Yes, sebenarnya tak boleh. That's actually basic one. So then later I will explain to you what type of the bottle that's suitable for the parameter that you want to test it. Okay, how much that we should store atau preserve, because sometimes when we collect the river sample, we reach in the lab at the late afternoon or sometimes evening, right? So the lab will close. Okay, sometimes the commercial lab, okay, maybe they are running until night. But for example, in FCAP, only 5 p.m., right? So you need to preserve your sample to make sure that it doesn't affect the quality. So if you what we call that, store or preserve in the correct way, so that means the water, the freshness you can keep, and then the data is okay, accurate. Okay, I think the rest during the sampling, I think this is common sense. Okay, rubber boots and so on, because we know that the sampling area is not really safe, so you need to have your safety precautions. Okay, documentation of course, this is also common sense, mestilah bawa kan, sample label, semua, how to label. Okay, this is our reference. Okay, if you want to collect water sample, you must refer to standard methods for the examinations of water and wastewater. Okay, so this is for the preservation. Which temperature that's suitable to preserve, to put. Okay, each parameter different method to preserve. So all of this you need to check in this one, preservation method. But the important is this one. Okay, that one I think just skip. Okay, what usually for PSM student, just talking about the PSM student because you are a student. So I want to relate with maybe in future you are taking a PSM for environment. Okay, commonly they will test on the BOD. BOD dekat sini, okay, COD, kat sini cuma ada dua je. Satu lagi, sekejap. Ammonia. Ini yang biasalah, common lah. Your senior will take the measurement lah, kan? If you want to have other parameters also you can. You need to check the what we call that, the standard method punya reference. Semua ada, right? Okay, just refer to this table found in the standard method. Okay, if you maybe you want to do the measurement for BOD, you can enter for example wastewater lab, okay, at FCAP or my lab, Micropolitan Research Center. So there we have the standard method you can refer. Okay, PGFP is the suitable container that you must use for sampling. P ni apa? P means plastic, but plastic is type is polyethylene or equivalent. So polyethylene, apa contoh polyethylene? Aku pula nak Google. Okay. Slow sikit lah ni. So ni dia botol-botol ni, yang warna putih. So the white one, actually we do have lots of quite numbers in the lab. But usually the students will use this type of the PET for water sampling, for collecting water. Okay, macam ni lah. So for the water sampling plan, they need to collect this bottle. They need to clean first. If we have a readily available, I mean the used bottle, students can use, but you need to clean, right? So they have also the cleaning process procedure that you need to follow. Okay, then glass pun boleh, tapi glass is heavy. Depends lah, if you are measuring the heavy metals, then you need to prepare a glass. Right, so this is the rinse process for you to clean. Okay, lagi apa? Then minimum size, okay, dia bagi how much volume you need to take. Okay, grab and composite is the type of the sampling. Okay, preserve. For BOD, okay, you need to check here. Okay, the maximum storage recommended. Okay, within because for because for the BOD, because we deal with the microorganisms, so it's good for you to within 6 hours you need to measure your BOD, or the maximum so you can keep your samples is 48 hours, 2 days maximum. Okay, COD pun sama, as soon as possible, or if you want to preserve, you need to put some acid to preserve it, and then within 1 week you need to do the analysis. Okay, and this is the temperature, must be below than 6 degree Celsius. Ammonia pun sama, but you need to preserve with acid if you want to keep in the refrigerator. Within 7 days you need to analyze. Okay, and the water sample same, polyethylene. Okay. Okay, I think that's all for the water sampling. Is there any question?
No, doctor.
No. Okay, before we end our session for today, I would like to ask, so that means we end our chapter 4 lecture for water quality. So next week is the what we call that semester break, 1 week. Then we shall to start our chapter 5 on water supply. So by this week I will put the slides in the author. Okay, dah letak saya lupa. So you may check lah. Okay, now is about the progress for your project. How many group that we have? Let me check in the author. Oh, 11 So we have 11 groups. Okay. So group number 1. Who is the leader? Group leader? Siapa?
Chris.
Chris, are you there? Oh, Chris is having a program, right?
Yes.
Jadi saya lah. So now your progress up until when? What? Saya mana dah?
Kita orang dah buat Google Doc, Google Doc lah apa? Google Form. Lepas tu dah distribute dah.
Google
Kalau
Form
yang,
distribute, then
kalau yang part masing-masing tu pun dah siap sampai metodologi.
methodology. Okay. You conduct any interview with the representatives ke? Ada?
Tak ada.
Ada. So your case study tu based on what? Your reference? Tak tahu.
Tak sure.
Yeah. Okay, sometimes group project ni dia bagikan tapi bila dia combine macam tak synchronize lah. So everyone please take note ya. Kena ada seorang yang baca balik lah supaya semua konsisten. Okay. Group number 2?
Yes, doctor.
So you are the group leader?
Yes, I'm the group leader.
So your progress?
We have made few meetings and we have done our questionnaire, and we already distribute our questionnaire. Then we have made we have called several organizations related to our project. So we have tried to make a meeting with them. And we have still going through it lah. Belum lagi dapatkan satu organisation yang ready to give us our interview, but still we are trying lah.
Okay. Alright, that's good. Any issue?
So far everyone is working very well in my team, so there's no issues right now, doctor.
Okay, that's good. Okay. Group number 3?
Hello.
Yeah.
Yeah.
Zaki.
Yeah. So group kami pun dah buat meeting untuk dan kami dah sekali dah settle dah tajuk, lepas tu ada beberapa objektif dan mungkin lepas ni program statement dengan objektif tu mungkin akan diberhenti daripada masa-masa. Lepas tu tugas pun dah bagi. Sekarang ni masing-masing dah buat daripada seluruh buat dan mungkin kita akan compile dan kita akan tengok maksudnya daripada intro sampai conclusion tu daily ke tak macam tu.
Okay. So you punya Google Form dah ready dah bagi? You punya survey dah?
Actually,
dah. Okay. Alright. Group number 4? Number 4 silakan. Your progress, okay tak?
Hello, Doctor. I'm from group number 4. My name is Chien Kai. So our chapter 1 and chapter 2 has finished already, which is introduction and literature review. I have let Doctor check and I have edited back, could do some correction, and then for the Google form, I did let Doctor check during week 2, and then I let my team member do some correction too, because I maybe there's some things that I lacking in the question, so I let my team member check. And for the other chapter, my friends are still doing it lah. So overall, we are still in good progress, steady progress. Yeah.
Okay. So have you have any contact? Did you contact with any organization?
No. No, because that's not compulsory to contact other organization, right, Doctor?
So your topic is on what?
wastewater treatment.
Oh. Not compulsory, but it is good if you can get the information on the current issue.
Current issue, yeah.
Yes,
Okay.
and you can discuss with them. There's a good opportunity for them. Not necessarily the higher up. You can interview the one who taking care of the logi, right? Or something like that. Or maybe
Oh,
engineer that know the concept of the wastewater. I think you will.
okay. Then I will let my teammate knows that we will try our best to find a interviewer so that maybe it will make our project much more concrete. Yeah.
Okay, okay.
Okay. Thank you, doctor.
All right. Okay, number 5.
Hello, Doctor.
Yeah.
I'm the leader for Group 5, Sachio.
Yeah.
So far our progress is we have done the problem statement, Google form and the interview questions. But the
Okay.
interview question and the Google form question, we plan to send to doctor for checking.
Okay.
We
You
still
can.
in progress preparing more
Oh,
questions.
all right.
And then the interview, we will conduct an interview, but we waiting for the persons to confirm with us the interview's time.
Okay.
Yeah, maybe next week on Tuesday, if not
Okay.
mistaken. Yeah, waiting for him to confirm with us.
Okay. Which company is that?
There is he's under F&B. I think he's a chef.
Randy.
Yeah,
Okay.
chef. Our topic is fat oil
FOG.
and grease from kitchen wastewater.
Okay. Okay. That's good.
Sewage pipeline.
Mm-hmm.
Yeah.
All right. That's good. Okay. So thanks chapter pula group number 5 for your progress. Right. Next number 6. Number 6, your progress.
Good evening, Doctor.
Good
My
evening.
name is Stephen. We have done our program statement, and now we are preparing our Google form, and we will prepare the question later. We will let Doctor to check our Google form before sending. And for the interview, we are still finding the industry expert to make an interview to
Hmm.
conduct interview.
Okay. Which industry is that?
Yes.
Which industry?
Still finding.
Finding. Okay.
Still finding.
All right. That's good.
Maybe in BP, Batu Pahat.
In Batupat, Okay, okay. If you have any issues or problem, maybe you need help from me, you can just asking to WhatsApp, Okay, group number 7. Okay, thanks.
Good
Seven?
afternoon, Doctor.
Yes.
Our group project progress is until the chapter 3, the questionnaire. Already prepared the question. Later we'll send for doctor to help us to check. And for the interviewer, we're still preparing the case, the interviewer which is suitable for the case. We're trying to contact the landfill Pulau Purong for our case.
Okay, okay.
Okay, thank you, Doctor.
Yes, Right. Then group number 8.
Yes, Doctor.
Hmm.
We already done the problem statement
Yes.
and the Google form and online interview is still in progress.
Okay. So your topic is on what?
Clinical waste treatment.
Clinical waste. Right. Okay. So if you want, every group, if you want to check, ask me to check on the survey, yes, you can. Give me the link, But it is good if you can make it by this week, because next week is our semester break. Ini sudah kan? Belum. Kevin dah. Yang ni dah keluar Lupa.
Dah.
Okay. Now group number 9.
Yes, Doctor.
Yes.
Okay, so for my group, I have done for the problem statement, and now we have done started to do the question for the Google form, and later we will give to Doctor to see whether it can or not.
Okay.
And the interviewer we will still fighting now.
Yeah.
Yeah, that's all.
So your group doing which topic ya?
Incineration technology.
Incineration dari your landfill ya. Okay, okay.
Yeah.
That's good. Okay, all the best Okay, that's good for group number 9. Then number 10.
Yes, betul. Untuk group 10, topik kami industry with air pollution control. So sekarang we have already done our problem statement and objective.
Right.
And for the interview question and Google form, we still not finalized yet. But for the company to interview, we already contact 2 companies and still wait for their replies. That's all.
Okay, right. Okay, that's good.
Okay, thank you, Doctor.
So now we are at week 6, yeah. So next week semester break. So please make sure that after the semester break, all out lah. Finish your, if you, I know that the interview is optional, but this is good if you can have some representative, alright, from the company or industry to get some overview of the current issues, right? And then I think for the Google form, if you have 5 members in your group, then each of the group can get 10, for example, 10, what we call that, 10 respondents, that would be good, right? So we can say like that. Then you can do the analysis. Okay, then our last group, 11.
Yes, Doctor. My name is Santiago, and we done the problem statement and the question for the online meeting and online survey. And later on, I will send the questions for Doctor check.
Okay. So which topic for your project?
Noise quality monitoring at construction activity and its control measure.
Okay, noise, alright. We're very related to civil. Okay, cool,
Okay, thank you, Doctor.
Alright. Okay, that's good. Semua lelaki Okay, then that's all for, that's good. So everyone's actually having their progress, okay? If you have any question ke issue, then you can contact me. Now is the attendance, yeah.